Hi everybody, this is Shivakumar. Today we are going to discuss about JEE Mains question paper 23rd January 2025 shift 1. Okay, so here we are having the first question, that is a light halo cube of side length 10 centimeters and mass is equals to 10 grams is floating in water. It is pushed down and released to execute simple harmonic oscillation. Then the time period of the oscillation is y pi into 10 to the power minus 2 seconds, where the value of y is. So we need to find out the time period. Okay. So first we have to write what is given data. So the given that the length is in 10 centimeters and the mass is 10 grams. Okay. Let us write. So length is equals to 10 centimeters and mass is equals to 10 grams. So here we are having 10 grams and 10 centimeters. So let us convert this into the meters and the kilograms. So 10 centimeters is equals to 0.1 meter and 10 grams is equals to 10 power minus 2 kgs. Right? So 10 into 10 to the power minus 3. Okay. So you got the 10 power minus 2 kg, and given that the acceleration due to gravity is equals to 10 meter per second square, and they given that the density is equals to 10 power 3 kg per meter cube. Okay, so here what happens, a hollow cube of side length 10 centimeters and mass 10 grams is there. So let us draw the diagram. So let us take this. Okay, so this is my hollow cube. Okay, half side L. L is equals to how much here we are taking? 10 centimeters we are taking. Okay. And it is floating. So it is floating in water. Let us take the water here. Okay, it is floating in water. Okay, so then what happens here? It is pushed down. It is pushed down and released to execute simple harmonic oscillations. Okay, simple harmonic oscillations. So then what happens? It is pushed downwards. So then what happened here? Then it will be move inside the water. So let us write here. Let us draw the diagram here. Right. So here we are having the water. Okay. So here, how much it get displaced? How much amount of the length is get displaced is about, let us take delta, let us take x. So from here to here we got the increase, right? So let us write x here. Okay, x amount of the volume of the cube is inside the water. So here what happens, after getting inside, then what happens, this pushes upwards. Why? Because due to the buoyancy force. Due to the buoyancy force, it will push upwards. Right? So here what happens, that buoyancy force gets to the restoring force of this. The buoyancy force gets to restore the force here. Okay? So buoyancy force of buoyancy is equals to restoring force. Okay, so here we are having the restoring force is equals to F is equals to ma. Let us take. Okay, so the buoyancy force. What is buoyancy force? Volume inside the water, density of water, and gravitational acceleration. Okay. So here volume inside. So how much volume it is inside the water? So here we are having the length of the inside the water is x. Okay, and the area is L into L. Okay, so let us take area A. X is the displaced amount of the length of the cube, and rho G is equals to ma. So restoring force here. Okay, so here what happens, the acceleration will be equals to A rho G by m into x. Okay, in simple harmonic motion we have seen that the acceleration is equals to omega square x. Okay, acceleration is equals to omega square x minus omega square x is there. But here what happens? Here when you push downwards, then the restoring force is upwards. So here what happens? Then we are going to get A is equals to omega square x here. Okay. So omega value. What is the value of omega here? Here that will be equals to under root of A rho g by m. Okay. We know that omega is equals to 2 pi by t. Omega is equals to 2 pi by t. Right. So I want to find out the t value. T is equals to 2 pi by omega. Right. So let us write the t value here. T is equals to 2 pi by omega. That means reciprocal of this. Then that will be equals to m by a rho g. Right. So let us take t is equals to 2 pi m. So what is n here? 10 power minus 2. 10 power minus 2. Area. Area means length into length. Total area of this. Here. Okay. That is L into L. Length into length. That is equals to, here we are at 0.1 into 0.1. That is equals to 10 power minus 2. Okay. So that will be equals to 10 power minus 2. And the density of water. So what is density of water? Density of water is given. That is 10 power 3 kg per meter cube. So 10 power 3. And here we are having g. So g value is the gravitational acceleration, that will be equals to 10 meter per second square. 10, right? So here we are going to get cancelled out these two, right? So t value is equals to 2 pi, and here we are having 1 by 10 power 4 is there. So let us take this 10 power 4 upside. So then what happens? This will become 2 pi under root 10 power minus 4, right? So let us take this. Let us remove this square root. So t is equals to 2 pi 10 power minus 4, and root value will be equals to 1 by 2. So this will be equals to 2 pi into 10 power minus 2. So here we are having that the time is equals to 2 pi 10 power minus 2 seconds. So here in the question here they asked about the y pi into 10 power minus 2 seconds. So we need to calculate y. So what is the value of y? The value of y is equals to 2. Y is equals to 2. Okay. Now we'll see the next question. Refer the circuit diagram given in the figure. Which of the following observations are correct? So the total resistance of the circuit is 6 ohms. And the current in ammeter is 1 ampere. Potential across AB is 4 volts. Potential across CD is 4 volts. And the total resistance of the circuit is 8 ohms. Okay. So choose the correct answer from the options given below. Okay. So here we are having that it is having the PN junction diode, right? So it is having the resistance of 4 ohms, and here also we are having the 4 ohms, and here also we are having the 4 ohms. Okay, so here this is PN junction diode is in the forward direction, it's forward bias. So for that reason we can draw this in this form. Okay, so this is forward direction, forward bias. So for that reason we need to take as a y. Take it in the place of this, we need to take it as a y. Okay, so the value of this is 4 ohms, and the value of this is 4 ohms, and the value of this is 4 ohms. Okay, and here we are having the voltage of 6 volts. Okay, so here what happens? These two are parallel to each other. So we have studied that the parallel. So then what happens? R equivalent of these two will be equals to R1 into R1, R1 into R2, that is 4 into 4 by R1 plus R2, that is equals to 4 plus 4, that will be equals to 4 into 4 by 8. So 4 ones, 4 twos, 2 ones, 2 twos. So R equivalent is equals to 2 ohms. R equivalent is equals to 2 ohms. So here let us draw this again. So here we are getting that 2 ohms, and here we are getting that 4 ohms. So that it is in a series, right? So it is parallel and it is in series. So series means R1 plus R2, right? So here what happens? The total resistance of this circuit will be equals to 4 plus 2, that is equals to 6 ohms. So 4 plus 2. So total resistance of the circuit is 6 ohms is correct option. And next, current in ammeter is 1 ampere. So what is the formula of current? Current is I is equals to V by R. Okay, so here we got that the R value is equals to 6 ohms, and given that the volt is 6 voltage. So the potential difference is given, that is 6 volts is given there, and resistance is equals to 6. So then we are going to get 1 ampere. So the current in the ammeter shows, here we are having the ammeter, and that is 1 ampere. And next, here we are having potential across AB is 4 volts and potential across CD is 4 volts. Okay, so let us see here. Here we are having C, here we are having D, here we are having A, here we are having B. Okay, so here we need to find out the potential differences, potential across CD and AB. Okay, so let us take that CD. First we'll see the CD. Okay, so what is the velocity? Sorry, not velocity, it is potential difference. Potential difference VCD. I am finding in between of the VCD. So V is equals to IR. So we have find out that I is 1 ampere. So 1 ampere, and resistance along between C and D, resistance between C and D is 4 ohms. So that is 4 volts. So velocity along CD is 4 volts. Velocity along CD. Sorry. Velocity, not velocity. This is voltage, potential difference. Potential difference across CD is 4 volts. So here you see potential difference AB is 4 volts given. So here it is not 4 volts. So 4 volt is already here dropped. So here what will total 6 and 4 is there. So for that reason we can tell that AB is not going to be a 4 volts. So here let us see the options. A, C, D. A, B, D is correct. So first we'll see A, B, D. So our option is 4. Fourth option is correct. And let us take the total resistance of the circuit is 8 ohms. Here we have already found out that is 6 ohms, right? So this is wrong and this is wrong. So for here what happens? The correct option is A, B, D. Okay. Next we'll see the next question. Given below are two statements. The hot water flows faster than cold water. So hot water flows faster than cold water. Yes, it is correct. Why? Because in the hot water we are having the in hot water we are having energy. So heat energy gives more energy to the water molecules. So for that reason the hot water flows faster than the cold water. And next here we are having the statement 2. Soap water has higher surface tension as compared to fresh water. So this is wrong. So we know that the soap water is lesser surface tension than compared to the fresh water. So here we are having higher surface tension. So higher surface tension is not correct here. Okay. So here what happens? Here we are having the statement 1 is correct, statement 2 is wrong. Statement 1 is correct and statement 2 is false. So this is the right option. Okay. Next we'll see the next question. So a spherical surface of the radius of curvature R separates air from glass. Of the refractive index is 1.5. The center of curvature is in the glass medium. A point object O placed in air on the optic axis of the surface, so that its real image is formed at I inside the glass. The line OI intersect the spherical surface at P, and PO is equals to PI. Then the distance of PO is equals to. Okay, so we'll do this one. First we'll draw the diagram here. Okay, so it is our spherical surface. Okay, so this is having the refractive index about 3/2. Okay, and having the radius of curvature is how much? Radius of curvature is R given, right? Okay. So here what happens? An object placed here, and image is formed here, and that here what happens here, the place a object is placed at in air, so this is O, okay, and the optic axis of the surface, so that it real image is formed at I inside the glass. I is inside the glass, so here we need to write I, and here we are having that the P, okay, so OP, so PO or PI is equals to same. That means, so the distance from here to here is equals to the distance from here to here. Let us take x. So the refractive index of A is equals to 1. Okay. So let us take this one. So here what should we have to find out? The line OI intersects the optical surface at P, and PO is equals to PI. Then the distance PO is equals to. We need to find out. Okay. So we need to find out PO. Okay. So we know that the relation between the what we call relation between refractive indexes and the radius will be equals to mu2 by V minus mu1 by U mu1 by U is equals to mu2 minus mu1 by R. Okay, see here we are having the object is in this side. Okay, so then what happens, incident rays will fall from here to here, so the radius is here, somewhere here. Okay, so that is radius is positive. Okay, image, so image is formed here, right? That means we are going to get positive, and the object is here, so for that reason we need to take negative. Okay, so here what happens, here we are having minus, here also we are having minus, so let us take place here. Okay, so mu2 by V. So what is V? V is equals to U here. Why? In question only they are given, right? What is there? They have given that PO is equals to PI. That is, let us take X value here, from here to here, and here to here also X value. So X minus mu1 by U. What is U? Minus plus here. We need to take place here. Okay. U. So what is U value? U value is equals to X is equals to mu2 minus mu1. Mu2 minus mu1 by R. Okay. So let us substitute the values. Okay. This is mu2 and this is mu1. So mu2 is equals to 3 by 2. So 3 by 2 and X plus mu1 is equals to 1. And U is equals to X is equals to mu2 minus mu1. So 3 by 2 minus 1. 3 by 2 minus 1. 3 by 2 minus 1 by R. Okay. So this value will be equals to, let's write here. So let us write here. Here we are having here 2. So 3 by 2x plus 1 by x is there. So in the denominators here we are having 2x and x. So let us equate by multiplying 2 on both sides here. This is not 21, this is 2. Right. So this will be equals to 3 by 3 minus 3 by 2 minus 2 by, how we got this? 3 by 2 minus 2 by 2. Okay, so 1 by 1 is nothing but 2 by 2, right? So 2 by 2 and R. So this value will be equals to 1 by 2 So let us take this one 1 by 2 by R. So this 2 is moves towards downwards directions. For the reason what happens? 3 here we are having that 3 plus 2 by 2x is equals to 1 by 2R. 2 will get cancelled out. So 5 by x is equals to 1 by R. X is equals to 5R. X is equals to 5R. So here we are having the 5R. Okay. Next question we'll see. See another question. What is the lateral shift? Lateral shift of the ray refracted through a parallel sided glass slab of thickness h in terms of angle of incidence I and angle of refraction r if the glass slab is placed in A. Okay, so let us draw the diagram of the glass slab, parallel sided glass slab. Okay, so this is our parallel sided glass slab here. Okay, so here first we need to give an incident light. So it is giving. So but what happens? It has to be move like this. But what happened here? Here due to the refraction, the incident light will get deflect here. Okay. So this is our normal. This is our incident ray. Okay, and this is I. I is angle of incidence. Okay, so after getting incident here, it will get refracted. It will get a refract here. Okay, then when a light ray travels from rarer medium to denser medium, then the refracted ray bends towards the normal, right? Bends towards the normal. So this is our normal, right? So it has to be moved like this. But what happened? It bend towards the normal. Okay. Next here you see when the refracted ray is there here. Okay, now it is incidenting here. Okay, so here first what happens, this air and this is our glass slab. So glass slab is having some what glass slab is having the refractive index, right? So here what happens? Here this object is h, having h height of the thickness of the glass slab. So here what happens when this incident ray is coming from the denser medium. When a light ray travels from denser medium to rarer medium, then the refracted ray bends away from the normal. So then what happens? This has to be moved like this. But what happened? It bent away from the normal. So see here this line and this line both are parallel to each other. Okay, so what should we need to find out? We need to find out the lateral shift. This is what we need to find out. Okay, so let us draw this diagram. Let us draw in detail. Okay, so let us draw this. So let us name A, B, C and D. Okay, so here this is our angle of incidence and this is angle of refraction. So what is this angle? This angle will be equals to I minus R. Why? Because here you see the angle, it has to become like that. But what happened here? It is bend towards the normal, right? What happened? Bend towards the normal. So this angle is I minus R. Okay, let us try. So let us take the triangle ABC. Triangle ABC. So there we are having the right angle at B. So here cos theta, cos R. Let us take cos R. So what is cos R? Cos R is AB by AC. That will be equals to AB by AC. Right? So here we are having AB. So what is the length of the glass slab? That is H. So here we are going to get H by AC. Okay. So if I want the value of AC, so what is AC? AC is equals to H by cos R. AC is equals to H by cos R. Okay. Okay. But we want this, right? But we want this. So how do we do? By taking this triangle ADC. Take triangle ADC. So at the point of D we are having the right angle. Okay. Now let us take the sine I minus R. So we want this, right? We want this. For that reason, we need to take sine. Okay, sine I minus r. Sine I minus r. That will be equals to the opposite side of the I minus r is equals to CD. CD by hypotenuse. So here we are getting this is my hypotenuse. That means ACD. So what we want? We want CD, right? So here let us take this AC from this side to this side. Then what happens? Then CD will be equals to AC sine I minus R. So we have already found out the value of AC. So what is that AC? That is equals to H by cos R sine I minus R. This is our CD. That means the lateral shift is equals to H by cos R sine I minus R. So this is our right option 31. Okay, next. Next we'll see, here we are having identify the valid statement relative to the given circuit instant when the key is closed. Okay, so here we are having A and B. Okay, R and key 5 ohms is there, 5 volts is there. So here we are having there will be no current through resistor R and there will be maximum current in the connecting wires. The potential difference between the capacitor plate A and B is minimum. The charge on the capacitor plate is minimum. Then we need to find. So here we are having that key when after the key closes. That means first we need to remember the graph. So IT, right? So we will get like this, right? And QT. So it will be more like this, right? Okay, so here we are having after closing the switch, there will be no current in the resistor. No, this is wrong. There will be maximum current in the connecting wire, right? This is correct. So here what happens? A is there here, A is there here. So we need to cancel out each other. And next we will see CD is there in the both. Okay, so let us take the B value correct, right? So B value is correct. That means first we need to take this one only. Okay, so we should not have to think about others. Okay, so let us do that one. So potential difference between the capacitor plate AB. So potential difference between. So after closing that, the potential difference between these two is 0. That is minimum. Okay, then this is also correct. And the charge on the capacitor plate is minimum. So we know that V is equals to Q is equals to CV. So we know that Q is equals to CV. So that means the potential difference between the capacitor plates minimum means automatically the voltage is also minimum, right? So we are going to get that the BCD is correct answer. Okay, so this is correct answer. Next we'll see. And here we are having that a solid sphere of mass m, radius r, is allowed to roll without slipping from the height. Without slipping, that means pure rolling, the highest point of the inclined plane of the length L and makes an angle 30 degrees with the horizontal. Then the speed of the particle at the bottom of the plane is V1. If the angle of inclination is increased to 45 degrees while the keeping L constant, okay, then the new speed of the sphere at the bottom of the plane is V2. Then we need to find out the ratio of V1 square and V2 square. Okay, so first we need to draw the diagrams. Okay, right. So this is my length. Okay, so first we are having this is 30 degrees. Okay, a solid sphere of mass m is there here. So it is rolled, pure rolling. Here we are having pure rolling. How we got that? Without slipping is there. So for that reason we can say this is pure rolling. Okay, so here it will rolls and comes to here. So the velocity here we are going to get that v1. Okay, next here what happens? Here the angle is 45 degrees. Then what happens? This is angle increased here. So then what happens next here? given they used the same solids here and released. That means release means here it is getting the pure rolling and coming back to here. Okay, making the velocity v2 here. Okay, making velocity v2 here. So we need to find out that the ratio of v1 square and v2 squares. Okay, so by using the conservation of energy, by conservation of energy. Okay, by using the conservation of energy. So here, what is the height? Here, so this is 30 degrees. So sine 30 degrees. Let us write here. So sine 30 degrees will be equals to 1 by 2. That means 1 by 2 means this is having L by 2, right? And here we are having this one, right? So sine 45 degrees. Sine 45 degrees will be equals to L by root 2. This is L and this will be equals to L by root 2, right? Okay. So here we are having the potential energy. So here we are having the maximum potential energy and here we are having the maximum kinetic energy. Here we are having the maximum potential energy and here we are having the maximum kinetic energy. Okay. So this is pure rolling, right? So here potential energy is equals to kinetic energy, right? Potential energy, total energy is conserved here, right? So potential energy is maximum and kinetic energy is minimum. That is 0 here. And here the potential energy is maximum, kinetic energy is minimum, that is 0. Okay, so at this point the potential energy is equals to mgh. H value is equals to L by 2. L by 2 is equals to, and here we are going to get the kinetic energy. So what is the kinetic energy? Half m v1 square. Yes or no? No. Why? Why? Because it is pure rolling. It is making pure rolling. That means we are going to get k plus 1. We are going to get k plus 1, right? Next, see, for this, let us take this mgl by root 2 is equals to 1 by 2 m v2 square k plus 1, right? K plus 1. So by what we want the ratio of v1 square, v2 square. So let us divide this two. Then what happens? mg will get cancelled out, L get cancelled out, 1 by 2 m will get cancelled out, and k plus 1 will get cancelled out. So the remaining will be equals to 1 by 2 by 1 by root 2 is equals to v1 square by v2 square. Okay, v1 square by v2 square. Okay, so v1 square by v2 square is equals to 1 by 2 1 by root 2. That means we are going to get 1 by root 2. So 1 by root 2 is our right answer. Okay, so next here we are having a subatomic particle of mass 10 power minus 3 kg is moving with velocity under the matter of wave consideration. The particle will behave closely like. So here we are having this much. So by using the de Broglie wavelength we can find this. So what is de Broglie wavelength? Lambda is equals to h by momentum. Yes. So what is the value of h? Here we are having that 6.63 into 10 power minus 34 by momentum, mass into velocity. What is mass here? 10 power minus 30 into moving velocity. Velocity is how much here? 2.21 into 10 power 6 is there, right? So by cancelling this, so 2 1s, 2 3s, and here what happened? This will be equals to 3 into 10 power minus 34 by, here we are having that 10 power minus 24. right? So by taking this 10 power minus 24 towards upwards, then we are going to get 3 into 10 power minus 34 plus 24. Then here we are going to get 3 into 10 power minus 10. 10 power minus 10. So where do we have the 10 power minus 10? 10 power minus 10 is about the wavelength of the X-rays. About the X-rays. So we are going to get the X-rays. So the given data, the given wavelength of the matter is about the X-rays. Okay. So here we are having the next question. The position of the particle on X-axis is given that A sin t plus B cos square theta plus C t square plus D, where t is time. Then we need to find out the dimensions of A, B, C by D. Okay, so we know that the sin theta, sin values we don't have the dimensions, right? Okay, so let us take here we have x. Okay, so x is the length, right? Is equals to a sin theta. So that means sin theta is do not have the dimension. So for that reason we can tell that a is having the dimensions of length, that is x. Okay, and next we will see b. So b is here we are having the cos square theta. Cos square theta means this. Theta means here we are having t. So cos square t is there. So cos trigonometric value. So for that reason this value do not have the dimension. So here what happens? B is also x. Right? B is also x. Position vector means here we are having position vector. So for that reason we need to take x here. And here we are having c t square. So c t square. T means how much here? T means time, right? C t square, right? C t square. So we need to find the c value, right? So c t square is equals to x. We are doing dimensionally. So that means this will be equals to L, this will be equals to L. C t square is equals to L. So I want the value of c. Okay, then what happens? This t square will come downwards. So for that reason we are going to get that t minus 2. Okay, c value this much, b value L, a value L, next d value. So what is the value of d? D is also equals to L only. Why? Why? Because here we do not have anything is there here. So for that reason we are going to get d is also having the dimensions of length L. Okay, position vector, they said that position of the particle they said. Okay, so for that reason we need to take this one. So A, B, C. So here we are having A, B, C. What is A here? A is equals to L. B is equals to L. C. C is equals to L T minus 2. L T minus 2 by D. D value is equals to L. Okay, L will get cancelled. So here we are having L into L square and t minus 2. Okay, so this is our right option. So the 35, the value will be equals to L square t minus 2. Okay.